Hello guys, good to be here again. The course is still neurophysiology by me. I'm Charles, the anchor and facilitator for this course. Today's lecture is on the hemispherical specialization. First, I'll make a brief introduction and then we'll look at the types of the cerebral hemisphere. We'll proceed to their functional comparison and then we'll wrap it up by looking at some of the highest functions of the cerebral cortex. Get your writing materials and please make your notes as I teach. Thank you. Alright. The cerebral hemisphere is one of the most prominent features of the brain. Alright? Good. Functionally, it is specifically important in language and communication. 2, in spatio-temporal relations, or you could call that visual-spatial relations. And then thirdly, in handedness, whether you are right-handed person or left-handed person. It is the cerebral cortex that controls handedness. I will look at that as we proceed in this class. There are 2 main types of the cerebral hemisphere: the left hemisphere and the right hemisphere. The left hemisphere is also known as the categorizational hemisphere. Alright? And it is specifically important in speech and language. Alright? So as I'm speaking to you now, it is the left hemisphere that is actually regulating or controlling the speech. But the right hemisphere is also known as the representational hemisphere, and it is specifically involved in spatiotemporal relations. What are spatiotemporal relations? I will find out as we proceed in this class. Going forward, both hemispheres are linked together by a structure or a fiber known as the corpus callosum. Alright? When this corpus callosum is damaged, it leads to split brain or double mind. The individual can hardly make decisions. Or you don't know whether to go. It's like you're telling yourself, should I go or should I stay? I mean, should I fall in love? No. Should I eat? Split brain. This is caused by damage to the corpus callosum. Alright? Now, this structure here shows the transverse section of the cerebral hemisphere. You can see the corpus callosum. This part of the brain is the corpus callosum. Alright? So, its function is to link the 2 cerebral hemispheres, the left and the right. Alright, in epileptic patients, research has found that reducing the corpus callosum helps to reduce seizures in these patients. Alright, now their lives are largely unaffected and seizures reduced to some extent, although their abilities to name objects are impaired. Alright, this could imply that people who are mentally challenged could have larger brain weights. There could be a correlation between larger brain sizes and mental disorders. Alright? Now, this could be true because a report has shown that the highest human brain ever recorded was 2,850 grams. Now, that is massive. And guess what? That person was found to be epileptic. So, there could be a relationship between larger brain sizes and epilepsy. Now, the solution could also be by reducing the brain sizes of all epileptic patients. Alright? Now, this is open for research. Alright? As a medical student, you could pick up a project in your finals, as in you gather all epileptic patients, measure their brain weights, try to reduce their brain weights and see if there'll be any improvement. You could also say, okay, let's see if there's any correlation between reducing brain weights in mentally challenged people, happy people, and see whether they would improve. It's open for research. Maybe reducing brain weight might be the solution for curing mentally ill persons in the society. The left hemisphere is often called the dominant hemisphere. The right hemisphere isn't non-dominant per se, because people refer to the left hemisphere as the dominant one, while the right hemisphere is recessive or so. But this is not true. The thing is, none of the hemisphere is dominant over the other. Rather, they have their specific roles in the human body. Hence, the name hemispherical specialization. Hemispherical specialization simply means the right and the left hemisphere, they have their special roles in the human body. Alright, going forward. Now, contralateral division of labor. Actually, the right hemisphere controls the left side of the body and the visual field, whereas the left hemisphere controls the right side of the body. I told you in the previous module that the cerebral cortex is different from the cerebellar cortex in their functions. Alright, so the right cerebral hemisphere actually controls the left side of the body, whereas the left cerebral hemisphere controls the right side of the human body. So whenever there is a damage to the right cerebral hemisphere, the left part of the body is affected. Conversely, when the left cerebral hemisphere or cerebral cortex is damaged, the right side of the body is affected. The right cerebellum or cerebellar cortex controls the ipsilateral side of the human body, that is the same side of the body, while the left cerebellar cortex controls the left side of the body. That is how it works. Going forward, now we shall look at the differences of the left and the right cerebral cortex or hemisphere. Now, the left hemisphere plays a specific role in speech and language. I've said this a countless number of times in this class. It is dominant in 96% of right-handed people and 70% of left-handed people. Okay? Now, for the right hemisphere, it plays specific roles in spatiotemporal relations, or you could call that visuospatial relations. We shall learn more of this as we proceed. It is dominant or more active in only 4% of right-handed people and 15% of left-handed people. Alright? Good. Now, this diagram explains some of the roles or specialties of the left and the right hemisphere. Go. Alright, the left hemisphere is involved in analytical processing and language. It controls the right hand and the right body parts. Alright, now mathematicians, scientists, writers, and logicians have their left hemisphere dominant or more active over the right hemisphere. Now, for the right hemisphere, people who are dancers, people who have musical abilities, also comedians, actors, even footballers and actresses have the right hemisphere dominant over the left hemisphere. Alright? So simply put, people who are artistically inclined have their right hemisphere hyperactive or dominant over the left hemisphere, whereas people who are scientifically inclined have their left hemisphere dominant over the right. The left-handed people are multi-talented. Oh, I can hear the left-handers singing, yay. Alright? And they are more skillful than right-handed people. They have a lot of skills. They are artistically inclined. Alright? Okay. The majority of artists, musicians, and comedians are left-handed people. Now, if you take statistics of artists in Nigeria, you'll find out that a majority of them are left-handers. Alright? Like the band, Two-Face, all of them. However, dyslexia, the impaired ability or the inability to learn to read, are very common in left-handed people. Okay. Also, left-handed people have short lifespan than right-handed people. Okay. I'm not saying that every left-handed people in this class or listening to me or watching this video will die today. That's not what I'm saying. But for reasons that are unknown, somehow left-handed people die quickly or earlier in life than right-handed people. All right. But the reason for this is not known. So good. Going forward, highest functions of the mind. All right. Some of these highest functions of the human mind include speech and communication, recognition of objects and faces. These functions cannot be found in animals. All right. Language, recognition of objects and faces, learning and memory, judgment, intelligence. All these are functions that are exclusively found in only human beings. All right. We'll take speech and communication today. In subsequent lectures, we'll look at other highest functions of the human mind, like recognition of faces and learning and memory, and so on and so forth. What is speech? Okay, speech simply means the communication between two or more individuals. All right. Language is the ability to express ideas either through speech or writing. You could express yourself by writing a note. Even a dumb person can express him or herself via writing. Okay. I'm speaking to you now. I'm expressing myself. I'm teaching you. I can tell you anything I want to tell you. That is language. All right. Good. Now, there are two means of communication. Okay. The first one is sensory communication. Under sensory communication, we have auditory communication and visual communication. The other one is known as motor communication. Under motor communication, we have the power of talking and writing. Okay. Writing is controlled by the frontal lobe. Alright, it's a kind of communication that has to do with movement. Is motor. Anything motor has to do with movement. Alright, motor communication. Power of talking. My lips and my tongues, they are moving to produce speech, the words that I speak. So it is motor communication. Now, when you talk of sensory communication, auditory communication, like as I'm teaching you are listening to me, the speech waves are entering your ear. The listener is actually in a state of auditory communication. All right. So visual communication simply means, reading. Okay, like you could read everything that is showing on your screen. This is visual communication. It's a sensory type of communication. Okay, good. Going forward, the brain structures or areas that are responsible for speech include: one, the Wernicke's area. This part is the Wernicke's area. This area here is the Wernicke's area. Okay, and then the next structure responsible for speech is the angular gyrus. This is the angular gyrus. Then we have the arcuate fasciculus. This area is the arcuate fasciculus. Okay. Then we have the Broca's area. This is the Broca's area. These are the primary structures that are involved in speech. Other structures include speech articulation, association areas, and then the motor cortex. Alright, we shall now look at the specific roles of these structures that are involved in speech, beginning with the Wernicke's area. It is area 22 of Bodman's. Now, this area is located at the posterior and superior end of the temporal lobe. Remember, we discussed all the lobes of the cerebral cortex. Alright, the temporal lobe is just slightly above the ear. So this part is the temporal lobe, and the Wernicke's area is located here. The Wernicke's area is specifically important in speech or language comprehension, understanding of language or speech. That is the specific role of the Wernicke's area. The other area is the angular gyrus. This is the angular gyrus, right? Good. The angular gyrus is just behind the Wernicke's area. That is the location. What does it do? It processes visual language, that is reading. So you are able to read what is written on this slide because of the angular gyrus. It is involved in visual language. So when this part of the brain is affected, reading is impaired. Okay, going forward, the aquate fasciculus. The aquate fasciculus is this part of the brain. All right, it connects the Wernicke's area to the Broca's area. This area actually projects auditory and visual language from the Wernicke's area to the Broca's area. Right? That is its function. So all auditory language that is entering the ear, every sound entering the ear goes to the Wernicke's area, and from there the Wernicke's area carries this sound stimulus to the Broca's area via the aquate fasciculus. Again, visual language from the angular gyrus are also carried by the aquate fasciculus to the Broca's area. It's very simple. The Broca's area is area 44 of Bodman. Okay, the area lies at the inferior end of the frontal lobe. Right? Good. The Broca's area processes auditory and visual language into coordinated patterns of vocalization. Alright, that is the function of this area. It actually processes, it works on the visual and the auditory language coming to it into coordinated patterns of speech. The other structure involved in speech are the speech articulation association area. This area projects the coordinated patterns for speech from the Broca's area to the motor cortex. It is the motor cortex that finally initiates the appropriate movement of the lips and the tongue and the larynx to produce speech. So everything goes down to the motor cortex. It then begins to initiate. It sends commands, motor commands to the lips, the tongues, and the larynx, causing them to produce speech. Right? That is how speech or speeches are produced. Going forward, articulation. What is articulation? Articulation means the muscular movement of the mouth, the tongue, and the larynx, and your vocal cord. This is controlled by the motor cortex. Now, it is responsible for the intonations, timing, and rapid changes in intensities of sequential sounds. Okay? We shall now look at the speech chain, speech production process. Now, the speech chain consists of the speaker and the receiver or the listener. For example, I'm the one teaching, so I'm the speaker here, and you are the listener or the receiver. Alright? Words are thought processes that are generated in the mind. These thoughts are generated in form of linguistics and phonetics, and they are sent to the motor cortex. The motor cortex now produces motor commands for speech. These motor commands are sent by the tracts within the CNS, motor tracts within the CNS, to the lips and the tongue, causing them to move. So the muscular movements of the lips and the tongue actually produces the speech. Now, this speech goes in form of waves to the receiver, to the ear of the receiver. Alright, when the speech wave enters the ear, it is transmitted to the auditory cortex, alright, via the auditory nerve. It is the auditory nerve that carries speech wave to the receiver's auditory cortex. the auditory cortex, is actually responsible for speech perception and what? Interpretation. Now, once the speech is perceived, it goes to the speech understanding center, which is known as the Wernicke's area. Now, the Wernicke's area processes the information and tells you that this is what the speaker is saying, and the whole cycle continues again. Okay, going forward, aphasias are disorders of speech, or speech disorders. Okay, so we'll look at them in details here. It is actually a problem that is related to the categorical hemisphere. Remember, the left hemisphere is specifically important for speech production. So whenever there is a problem with the left hemisphere, you have aphasias, that is speech disorders. Aphasias result from damage to the speech centers within the left hemispheres. Alright? Now, they don't cause damage to the sight or hearing. Neither do they cause paralysis. The damage is only restricted to the speech centers in the categorizational hemisphere. Okay, so it does not affect the optic nerves or the auditory nerve, or those centers or structures that are involved in vision and hearing. Alright, good. Going forward, now we shall look at the different types of aphasias and their causes. So expressive here is telling you the type of aphasia, and receptive is telling you the area or the speech center that is actually affected within the left hemisphere. Now, for non-fluent aphasia, understanding is normal, but voice production is defective. Now, whenever understanding is normal, the structure that is involved or that plays a vital role in language comprehension or understanding is the Wernicke's area. So the Wernicke's area is normal here, but the structure that is involved with speech production is the Broca's area. So in non-fluent aphasia, it means the Broca's area is actually affected or damaged. So speech production is abnormal, but speech comprehension is normal. Alright? Good. And then we have the fluent aphasia. In fluent aphasia, the words the person is producing are meaningless, senseless. The person is talking, but it's not making sense. You know when someone is talking balderdash? Okay, that is fluent aphasia, with loss of comprehension and understanding. Alright? Now, in this person, speech production is not affected, but the words being produced are abnormal, senseless. You can't make anything out of them. So the area of the brain that is affected here is the Wernicke's area. Okay? Alright, in conduction aphasia, the problem lies within the arcuate fasciculus. That is, in conduction aphasia, auditory and visual language cannot be transferred from the angular gyrus and the Wernicke's area to the Broca's area. You remember that the acute fasciculus actually transfers or transmits auditory and visual language from the Wernicke's area and the angular gyrus to the Broca's area. So when the arcuate fasciculus is damaged, conduction aphasia occurs. Alright? The next one is anomic aphasia. Alright? Here, there is inability to name objects. This type of aphasia is caused by damage or problems in the angular gyrus. Alright? And finally, we have global aphasia. Global aphasia comprises of all the other three mentioned earlier. Okay, so in global aphasia, speech production is defective, speech comprehension is affected, both auditory and visual languages are all affected. It comprises of all the aphasias. Alright, so it is actually widespread damage to the speech areas. So it means that the Broca's area is affected, Wernicke's area is affected, the angular gyrus is affected, the acute fasciculus is also affected. It is global all round. So this person is not fluent, comprehension is lost, visual language that is written is also impaired, even auditory language is impaired. So that is global aphasia. Is a mixture of all of them, all the aphasias. Okay, going forward. Now, there are also other areas that are affected that could cause problems with speech and communication. This includes the auditory association area. When the auditory association area is affected, there is word deafness. So every word I'm speaking, you may not hear them when this area of the brain is affected. The next one is visual association area. There is word blindness. You cannot read what is on the slide. Alright, that is a problem with visual association areas. Damage to visual association areas will cause impairments in reading, word blindness. Alright, Wernicke's aphasia, we have said that before, unable to interpret thoughts, that is, there is loss of language comprehension, and Broca's area causes motor aphasia, speech is lost, speech production is affected. Global aphasia, like I said earlier on, you're unable to interpret words, you're unable to even produce the words. There is word blindness, there is word deafness. All of these are problems that could be associated with speech and communication. Okay, going forward. Alright, global aphasia is actually discussed in details in this slide. This means the combination of the expressive problems of Broca's aphasia and the loss of comprehension of Wernicke's area. Okay, I mentioned that earlier on. The patient can neither speak nor understand language. So there is inability to produce the words, and there is also inability to even understand words. Speech production and speech comprehension are all lost in global aphasia. It is due to widespread damage to speech areas, and it is commonest aphasia after a severe left hemisphere infarct. Okay, I take it again. It is due to widespread damage to speech areas, and it is the commonest aphasia after a severe left hemisphere infarct. That is infarction of the left categorizational hemisphere. What is infarction? It means the cells around that area are degenerating. They are becoming dead due to poor blood and nutrient supply. Infarction. Alright, good. So this infarction of the left categorizational hemisphere is the commonest cause of global aphasia. Alright, writing and reading are also affected, as I said earlier on. Okay, wow, we have come to the end of today's lecture. It's been so interesting and so educative. I hope that you learned something today. Good. Our quiz for today is a very simple one. Just discuss the role of the brain in recognizing objects. Recognition of faces and objects is also one of the highest functions of the human mind that are only found in humans and are not found in animals. So that is a simple quiz. That is the most simplest quiz in the world. Do your assignments and submit before the next class. Up next is tracts of the CNS. So in module 3, we'll discuss the tracts of the CNS, ascending tracts and descending tracts of the CNS. It's going to be mind-boggling, so it's not a class to miss. Otherwise, if you miss it, you will regret. Thank you so much for tuning in. I remain humble and loyal. Charles, your uncle, and the presider for this course. Let's do it again next week. Thank you and good night. Thank you and goodbye.